Hi everyone, my name is Paul Bouchier. I was asked to give a talk on a gentle introduction to ROS. Hey James, glad you came. And the topics here, what do you have to do to run it, how do you install it, how do you set it up, and what are its parts, and how do you use it at the most basic level. So I'm going to go over all of those things. There's a lot behind that, so we're going to be moving fast and covering a lot of ground, so fasten your seatbelts and let's go. We're going to actually do a installation of ROS live here, and we'll do demos in between while we're waiting for action. We're going to talk about ROS installation and concepts. I'm going to go through a little bit of C++ and object orientation. My assumption here is that people, for the most part, run Windows on their laptop, or maybe they have Macs. Not too many people run Linux on their laptops, so I think that if you're looking to get your feet wet in ROS, you probably don't want to give up your whole environment that you've got your email on and everything. If you've got another laptop, then fine, that you can sacrifice and give to the cause, then great. But otherwise, I suggest you can go a long way down the path by using a virtual machine. And so I'm going to do the install in that, and then the install of ROS. But the OO concepts and C++, you'll not going too deep into that, but you'll very much appreciate that. Why was ROS invented? Well, this is probably too small to read from back there, so I'll read it. So this is really the problem that ROS was designed to solve. Someone publishes a paper with a proof of concept robot, and that prompts another lab to try and build on that result. But they can't get any details on the software used to make it work, and all the code that was used by previous labs is a mess, so they make a grandiose plan to write a new software API. And they spend countless sleepless nights rewriting the software from scratch, but inevitably time runs out. Remember, these are PhD students we're talking about here, and they write code that barely works but lets them publish a paper with a proof of concept robot, and round we go again. University researchers were rewriting the same stuff, the same motor control, the same PID algorithms, the same vision logic, the same navigation logic, so that they could publish their particular algorithm for whatever it was they were researching. ROS was designed to fix that problem of reinventing the wheel from scratch by standardizing interfaces and components, and by defining an architecture and a community which allowed for composition of robots using relatively fine-grained components. So the essence of ROS is that you take relatively fine-grained components, like a sensor component for a LiDAR, a sensor component for an odometer, a sensor component for a robot, or maybe you have to build one or two of them, but the rest of them you can likely get from the community's repository. And then you compose them into software that will run a robot. And there's a huge number of packages that are available on the ROS wiki. So if you go to ros.org and the wiki, you will find this page where you can browse software, and I'm just going to skim down here to give you I'm just going to scroll real fast to give you a feel for the number of packages. There are about 1,500 packages doing everything from diagnostics to dynamixels to lasers to fingertips to quadrotors to... Okay, hopefully I made the point. Okay, so let's start running getting the VM install going. I've already installed a virtual machine. I suggest VirtualBox. It's a robust virtual machine. Does everyone know what a virtual machine is, or should I like introduce that?
Cover everything, Paul.
Okay. Okay. So a virtual machine is a software emulation of a computer. It has all of the attributes that you would find in a real hardware, like just virtual CD-ROMs, memory, CPUs. It simulates a computer at a low enough level that it even fools the operating system into thinking that the operating system is running on real hardware. So the idea is that you install, if you're running in Windows, you install the VirtualBox software, it pretends it's a whole computer, then you install Ubuntu Linux, which is what you need to run ROS on, in the virtual machine. Ubuntu doesn't know it's not in a virtual machine, and so it just runs ROS quite happily. It's a bit like, remember in the Matrix, you had the blue pill and the red pill, and one of them made you think that everything was rosy and you were in a nice, beautiful city and everything. The other one made you let you see reality, which is all these humans in vats getting like blood sucked out of them. So virtual machine gives the operating system, what color pill was it?
Blue one.
The blue one. Okay. With that, let's kick off the virtual install. So we'll click New to make a new virtual machine, and we'll call it ROS, and its type is Linux. It's Ubuntu 64-bit. I generally crank the memory size up to a couple of gigabytes, just to give the operating system enough room. Leave it set to create a virtual hard drive now. The virtual hard drive actually becomes a file on your Windows computer or whatever, Mac, whatever computer you're using. And that should be it. Create it. It asks us how big a disk space we'd like in this computer. And I normally crank it up to about 20 gigs. It's not a whole lot by today's disk drive standards, and it's plenty enough to run Ubuntu and Linux and ROS in. And dynamically allocated, we want to leave that set, meaning it will start off allocating maybe 1 meg or 4 megs, how much it needs to install Ubuntu, and it'll grow it dynamically as you add more stuff. So it's pretty smart.
So is this different than what you call just like a straight dual boot?
Yes, great question, very different. Dual boot is where the operating system runs on the real hardware, and you can only run one operating system at a time. A virtual machine has, as I said, a software emulation of a computer in it, and so it's running underneath the host, or actually on top of the host operating system as an application. So if you run, look at your applications running in your host Windows or Linux operating system, you'll see something called VirtualBox. VirtualBox is an application that's running the Ubuntu operating system that is running its own stack of software.
So you're using it because it does something for you that a dual boot setup would not do?
Well, I was assuming that the people here wouldn't necessarily, either maybe wouldn't know how to set up dual boot, or wouldn't want that sort of bimodal nature where you've got to boot up into one or the other. I was assuming that people would prefer to keep Windows active so they can play with email and whatever, but also have Linux going so they can work on ROS and can save away. Here's another nice thing. Just like you can hibernate a Windows computer, you can hibernate the VirtualBox. And so put it to sleep for, till next weekend when you get to play with it again. Okay? All right, so we made a virtual machine here.
But I was just wondering,
one quick question.
Yeah,
Okay, this is, if I had set up Ubuntu as a dual boot, but we're still going one level deeper, right? You're now saying within Ubuntu, you're gonna set up a ROS virtual
well,
machine.
so
No.
if you have Ubuntu already set up as dual boot or whatever, I recommend you don't bother with the virtual machine.
Oh, okay.
You just run it natively, install ROS, it'll work great. You would want to probably have Ubuntu 14.04.2, which is the latest, and just run it natively. One thing, these virtual machines are so smart that they even can pass hardware through to the virtual machine. So particular kinds of hardware, the USB serial is an important one because so many peripherals like LiDARs and compasses and you name it have a USB serial interface. And you can tell the virtual machine to grab that interface away from the host operating system and present it to the operating system in the guest. So the terminology here, the host is the operating system that owns the real hardware, and the guest, you can have one or more guests running, are running in the simulation. They took the blue pill.
Is Ubuntu required or are other Linux, like Mint or something else, Debian?
ROS requires Ubuntu, and it's particular, well, okay, there are some...
Mint is an Ubuntu derivative. It just happened to the GNOME desktop instead of the Unity crap.
Jason, what are you running?
So we could say in the sense of, it will run on Mint.
Okay.
If you want to spend the 2 days making it run on Mint.
Okay.
So if you want it to run in 30 minutes, use Ubuntu. If you want to spend a bunch of time troubleshooting the library variances in Mint, and they do exist, run Mint.
Okay.
So there are plenty of people who have written the documentation on the wiki to do exactly what you just described, run it on Mint and the Ubuntu derivatives, not the Debian derivatives.
Right.
Because Debian's a whole nother ball of wax.
Exactly.
Even though Ubuntu's based off of it, it's so far gone from it that you can't really call it the same thing anymore.
Just real quick, so if you were setting up ROS just on a Windows box, you'd say go this route, because don't go set up Ubuntu and then set up ROS with it. Rather, just set it up all under Windows.
I'm assuming that, okay, as we go through this, you'll see ROS is kind of a heavy lift in a lot of ways, and quite a steep learning curve. And so I'm assuming that you don't want to like give up your whole computer while you're learning, while you're getting your feet wet. That you want to like try it, play with it before you commit a computer to it.
Yeah, if you're ready to commit a whole computer to it, don't bother.
Yeah, but if you've got a spare computer, then hey, use that.
When you get to the point that you actually want to use it, you want to get rid of that virtual machine.
Yeah.
Okay, so
Yeah.
there's overhead.
Yeah.
Because the overhead kills
Yeah.
what you're trying to do.
Yeah.
And so like some of the stuff I'm going to show you when it comes to the visualization and the navigation and the cost map algorithms.
So that's where the dual boot, like if I took my machine and could partition some off for Ubuntu,
Right.
do that, install
Yeah.
Ubuntu, then install.
Right,
Right, but
right.
you probably don't want to make that leap until you decided to make the actual push. And a VM's cheap to do it with.
Yeah.
If you don't like it, you press delete and you go back to what you were
If
doing.
you're going
So-
to dedicate a computer to it, what are the minimum specifications required?
Well, so that's an extremely hard question to answer. What are the minimum specifications of your robot you're going to build that you want it to use? If it's going to have 3 stereoscopic cameras and 4 GPSs and a whole bunch of other jobs, you got to have
keep
a.
it within the realm of reasonable.
Well, so when you get the ROS, that is kind of reasonable in
Well,
the sense
so-
that runs 2 visual sensors, has 3 gyros.
Okay.
So I mean, it all depends on the.
But at the other end of the scale, I'm running it on a little netbook there that is, like a, couple of gigahertz with, 4 gigs of main memory. It'll run perfectly happy in small configs. But like Jason says, if you want to run RViz like he was showing there, you want something with decent graphics. But so this was a beginner's talk, and so I was trying to explain things that would be, help you get your feet wet without committing to it totally until you know whether you want to do that.
Because obviously, if you're gonna spend money for that much hardware on the robot, you can spend a couple $100 for another wire.
Exactly,
It
exactly.
hits the
Yeah.
one sitting on top of it.
Okay, so we're going to install Ubuntu, and so you go to the settings for the virtual machine, and what you do is you click on storage, and so now this is where we're going to attach a DVD to it. So this is a little icon that currently shows empty, so it's a simulated CD-ROM. So we go over to this little drop-down and we say, choose a virtual CD or disk file. So in the instructions, I had you download Ubuntu 14.04.0.2 as an ISO. So you just connect to it. And hey presto, now the computer, the simulated computer, thinks it's got a CD. It runs a BIOS, like a real BIOS. It's going to boot off of the CD, which is, simulated. So now we just power it on, and we should see it start booting up ROS and ask us some questions, hopefully, if I did remember to do everything.
Is it not gonna boot Linux first?
Well, no, remember, we just made this machine from scratch. It has nothing on its disk. It's got a blank disk, blank hard
It's gonna
drive.
Install Ubuntu on it.
So it's going to install Ubuntu on it. So,
Of
what?
course, you can download one that's already pre-built if you.
Yeah, there
search
are some.
around.
Yeah.
So these are ROS messages that are printing on the screen right now?
These are Ubuntu.
I see, you said ROS, that's what threw me off.
I'm sorry.
Okay.
I'm sorry. Okay, so this is the standard Ubuntu install screen. So we want to install Ubuntu. And this is just kind of like installing Windows or anything else. And we just continue. And we want to erase the disk because there is nothing, on its disk. It's a new virtual machine. And yes, fine, it's going to overwrite the disks. The Ubuntu installer, so it's running a live CD in simulation at the moment. So it's effectively as if you plugged in a USB live CD drive and booted off of that. It's pretty slick. We're in Chicago time zone, and our keyboard layout is US.
Are you sure we're in Chicago?
And I'll give my name as Bouchier,
Are we in Kansas?
and you can change the computer's name, ROS VM, pick a username Bouchier, pick a password, Bouchier. I always click login automatically just because and don't encrypt my home folder. Just because, if I'm on this computer.
You are.
Okay, so now it's installing, and yes.
Will the virtual machine simulate a DVD on a laptop that has no DVD?
Yes.
Sure.
Yes.
You can just mount the ISO.
It's just
Okay.
it's a software emulation of a DVD. So you just connect the software emulation of a DVD to an ISO file,
Okay.
and away you go. It doesn't know. It took the blue pill. It doesn't know any different.
Yeah.
Um,
The harder translation handles all that, so you don't have to mess with it.
Okay.
So this will take a while, a little bit to install. So I'm going to switch over to Jason to do a demo now.
Does the virtual DVD have to spin up somehow?
Yeah, you turn the laptop round and round.
You can hear volume up on the speaker, you'll hear it making. Was it really?
Seek error, I'm sorry. Oh, I brought, okay, wait a minute.
Come on, read the stupid display.
Yes. We got somebody coming.
All right, so this is a this is getting into a little bit more after you've spent a little bit of time in ROS, you'll get to the point that you're doing navigation with your robot, obviously. There's a lot of ways to build, to do navigation with your robot in ROS. In particular, this robot that's up here in front uses a XTN Pro sensor, which is basically a Connect-like device. Uses a little bit slightly different technology, not very much, but has different angles, different distances, but none of that really matters. It does a 3D depth scan and creates a point cloud of a 3D image of what it's seeing. And then the laser scan is a 2D slice halfway from the top to the bottom. And that's the laser scan that gets pointed back to it. On the screen itself, you can kind of see the laser scan points by these little white dots right here. It's kind of hard to see, but these little white dots are what it thinks the laser is seeing. Now, that does lead to a limitation with the way I currently have it configured. It can be reconfigured. You can see me walking into the screen now. Okay? It's detecting me right about here. Okay? So anything down here, it actually doesn't see at the moment. It doesn't include as part of its map. Anything above here, it doesn't see at the moment. It doesn't include in its map. When I run this in my normal configuration, I actually slice it at 3 different heights, and that's how I publish my scans. And so I actually slice it close to the top, close to the bottom, and in the middle, so I can at least have 3 levels of mapping. I didn't want to get that complicated here.
Beginner's class.
Yeah. It's a pain. You could do it, and not many people actually do it with the turtle bots until university level. It's something I discovered about a year ago or so. Anyways, so as you see on the screen, this is a map of the room. Before people sat in the chairs, these are where the chairs were at, back there in the back of the room, which is okay, doesn't matter. This is where these chairs are stacked up over here. This is the wall over here. There's the trash can behind everybody over there. And here's the hallway you guys entered to come in. This, I went out and just turned around and came back in, so that's a single scan map, nothing major. You can actually now, with the robots that you have all the motor and motion set up in, automate the making of the map by driving to the largest space program. It's a really simple, stupid program. So you set up, hey, make me a map, and then you tell it to automatically drive to all the largest spaces in the room. And so it'll drive around the room just finding large spaces, and in the process make a map of the room. And then you can drive it out in the hallway and tell it to do the same thing, and it'll drive to all the large spaces and make a map of the hallway too. That way you can automate your map making, so it just becomes a part of the process. If you move into a new building, click, and it just goes and does its job. You can also set that stuff on startup and all that other jazz if you want to go down that road. Again, didn't do it for this demo because it wasn't necessary. What's on the screen now is the produced map from me driving it around earlier. This section right here is where it's showing my cost analysis of moving. So it's a gradient, as you can see. The further away from the robot, the less sure it is what's actually still there. Kind of makes sense, right? Because it knows what was there the last time it was there. But it'll try to figure out if it's still that way as it gets further away. As what's close, it knows dead on what's there because it's there. Does that make sense? It sees it. And so in this, when you first start this program with the map, you have to. There's a common issue with navigation of this type is it's not easy for the robot to tell where it is to begin with, if that makes any sense whatsoever. So it's kind of, we're working towards that goal. In fact, we're pretty darn close. To the sense of, I just put it down in the room, it'll turn around in a circle and then go, oh, okay, this is where I'm at. In fact, that's actually what we're doing. And so as long as some of the room looks the same, it'll be all right. But what we're really trying to figure out is the difference between walls and other obstacles for it to determine the rooms lengthwise, widthwise, so on and so forth. Anyways, so you have to tell it what its pose estimate is, and that's what this is. So when you put it down, you tell it what direction it's looking in, And I'm not gonna do that because I know where it is right now. And there's these little green arrows where it expects its pose estimate is. When you drag the arrow, it'll put a cloud of those green arrows until it actually is guaranteed it knows its pose estimate like it does now. And so if I wanted it to move to the corner of the room, I click in this area, and where the arrow is, see that arrow? Is the direction it'll be facing when it arrives in that location that I clicked in. And right now, it's making a red line to green line. It doesn't know for sure yet. Red line, it kind of knows. Green line, and as you can see, it's building its view map along the way until it gets close to its destination, which is an XY coordinates based off the map. And then at this point, it turns into the direction that I told it to be at the XY coordinates of where it is in this room.
Jason, how big is that map,
Space-wise,
memory-wise?
Is it like pixel, you're thinking each pixel is a chunk of information?
I think the short answer is you can declare the map scale, so it's a pixel per whatever you declare.
And what is it currently?
the pixel map, the PGM right now is 191. Okay.
1.9 megs.
Is that 1.9?
No? You're right, 191K.
No, it's 191K.
Yep, sorry.
The megs go another one.
You're right.
So,
Sorry.
in memory, it's a little bit bigger because it's an adaptive map. Right now, I have an adaptive portion in it because I expected people to change the configuration of the room, and so it's storing what the objects were, and now where the objects that were is.
So is that twice as big?
Right now, I'd say it has about another 2/3 of the actual space taken up. And so I can actually drive it from corner to corner.
I guess the question is the visual representation, does that contain most of the information?
So the visual
Is that
representation,
the information?
that's the information mainly.
Okay, so
The
it's
visual
doing
repre-
searches on that bitmap. It's looking,
But
there's a
it's looking-
program looking at that bitmap.
So this is a pretty version of what the actual map looks like. The actual
Okay.
map is a set of X and Y coordinates and points with layouts and this big, yes.
Oh,
Yes,
okay, there's
pictures.
connectivity information, contour.
And so this is pretty.
Okay.
And it's point to point to point to point to point to point of the laser scan. I can reduce the map by about to 1/5 the size by doing a map analysis that removes and adds in curves and those type of things and makes that wall all one line that says it's from this point to this point type of scenario. But I didn't do any of that in this situation because I was just trying to get something to show that works. And that gets into a lot more advanced ROS stuff than what we're trying to do. This particular stuff, once you get being able to drive the robot around and it being able to sense the area, which can either happen by bumpers, ultrasonic sensors, IR, however you want to do it. It can derive a map from that. Once you get your navigation down and your localization working, you can actually do this just by plugging in your navigation module. Then you create a map. Then you save the map, and then you load the map. Step by step by step. So you can actually go down the road of, so this is like the next step from the basics. Great, I got my robot moving. It knows where it's at. Now I can create this map. I can navigate to where I want to navigate to. And now I can programmatically tell it where to go in this map. So like in the area of what I was doing for Can, robot can soccer, is I told it the XY coordinates of the cans. It determined the quickest route to collect each can and get it to the goal and get back to where the previous can was along the way. So it actually did a cost analysis, and if there was another robot that was gonna step in the way, it mapped a path around it to get to the can. Scarily enough, it would just take the robot to, it was in the same spot as the can. Because it doesn't care, it's just a can at that point. I've modified the bumper control to actually determine something's heavier than a can, because a can doesn't fire off the bumper, but most robots have.
What's the grid up there?
This is just a grid that I have drawn on the screen.
Okay.
You just turn it on and off. It was so I could grid out my mapping. It's just, it's anality is what it is basically.
Question?
Yeah, I have a quick question. So is there any way to specify a weight or priority to one particular sensor over another? So
Absolutely.
vision may override odometry or something like that?
Absolutely. Some people will argue with this statement, but I actually think this is more along the lines of the way you build the robot is kind of the same way that basic substation works. Is it has a base layer. This thing has a base layer too. The bumper sensor, if that hits, the edge sensors, if those hits, it does not care if the navigation is telling it to drive off the cliff. It just ain't gonna drive off the cliff. So it has a set of layers that you build up for the base all the way up to the top. And this is just the high level stuff telling the base to go. And the base has these sensors that go, dude, you're trying to drop me off stairs. I'm just gonna sit here until you tell me not to drive off the stairs. And I'm telling you, there's a cliff here. So how do you want me to handle it? And then your upper level logic goes, oh, I'm not really there. Let me find out where I'm actually at. Though I haven't really had that issue, once we got past getting the odometry and the sensory stuff, it's pretty darn accurate. I can get it down to about 1/4 of an inch or so. Click, and that's where it goes, or programmatically, that's where it goes.
So this is, how many days of pure effort to get to this point?
So I came in today with ROS already installed, so doing what Paul's done.
Yep.
This already built. So that was like 30 minutes to put the screws in, okay? Because building the TurtleBot was easy. Plug into USB cables, install ROS 2 machines, so about 4 hours just to install and building. I made it do this with precursor knowledge of knowing what I'm doing in 45 minutes.
Okay, but I can read David's mind, and what he's really thinking is, well, how much time do you have in ROS, period, you know?
Probably about 700 or 800 hours.
Okay.
But this is basic stuff. I was doing this with the Create and the TurtleBot 1 series stuff within a week or two of getting the Club TurtleBot and playing with it. And that was me relearning ROS, relearning Ubuntu, relearning ROS and its configurations, because this type of stuff, they make tutorials step by step by step by step. And I'm sure everybody in this room knows how to Control C, Control B. That's really what it comes down to. Now you have no clue what's going on. That's when it starts digging into the deeper bowels of things. And so like when I have this at home, I don't use any of the tutorial stuff. I have all customized stuff just for the house, which I can't run here, because I haven't made it dynamic enough to be in this environment. That is what I'm working on towards those, so I can just take it into any building, it maps it, and then knows where the things are that I care about, takes care of it. So that's it for the demo. Is there anything else anybody else wanted to see? Like you can actually see the image that's coming from it if you want. You can.
We might be under a time constraint, so we probably
Yeah.
move on.
Yeah, we need to roll, guys.
Nice demo. So, very very appropriate demo for Pi Day. I forgot to welcome everyone to Pi Day.
Super nice.
And so, having just seen this glitzy demo, and by the way, Jason is brilliant, and he knows how to do these fancy things, and I don't. So I'm still down there. But neither have I put 700 or 800 hours into ROS. But there's a question that I really want to address. It's sort of higher level, and it's perhaps best exemplified, and it came across the mailing list when this talk was first proposed. And the question is perhaps best expressed by, do you guys know the difference between a scientist, an engineer, and a technologist? So scientists want to understand nature. They study nature, they discover how nature works. They don't really care much about building stuff, right? Engineers want to build stuff. They want to make it as fast, reliable, cheap as they can. Technologists just want to play with technology, and that's all they care about. The more complicated, the better. Okay, so the question that David really was, what was behind his question was, aren't you guys just technologists? And I think I want to say that the answer is no. What we're trying to do is to understand a larger piece of robot software than we're capable of building, of all the pieces of it, in order to build more complex robots. So that's what ROS is really about. None of us have the, I think, the time and probably the skills to create that kind of mapping algorithm that you just saw in operation. But once you can learn enough about what other people have built, then you can add your own things, like put it on your own robot and write your own component that will drive your particular robot and integrate it with the rest of ROS by using standard interfaces that ROS defines and composing a robot software system out of pre-existing modules that you got from the ROS repositories plus whatever modules you wrote. And so that's what I've been doing on this. I wrote the module that drives the robot. The laser scanner is, the part of ROS software is available for that. There was, I worked on this to improve it. ROS has a community, and you tend to work with people all over the world when you work on this. So I was looking for this is a Razer 9DOF, a SparkFun Razer IMU 9DOF in there, and I was looking for software for it. Found someone had published some, but it didn't work right. It was its coordinate frames were upside down and various problems. I found someone else who had fixed some of the problems and worked. So this first guy was in Malaysia. Second guy who fixed some of the problems and wrote that he was the maintainer in the source code, and contacted him and the original author, and they agreed to transfer maintainership. He's in Belgium. So I've been working with him. I wrote a bunch of the documentation and put it up on the web for that module. So just to say that to emphasize the composability of robot software from these modules that you can pull from all over the world. Okay, back on our Ubuntu install. It took about 10 minutes, but installation completed. And so just like when you're booting Windows, or when you're load installing Windows or Ubuntu, it wants to restart. It unmounted the CD automatically for you. So you just say restart now. So now, since there's no CD, no virtual CD in the drive, it shuts down the live disk, then reboots. Now it's going to reboot off of the hard drive, virtual hard drive. And I did see it actually hang here. And so we're going to get the opportunity to force it down. And what you can do is just, if you press the X button, as you'd expect, it shuts down the virtual machine, and you have several options. The most interesting one is to save the machine state, usually once you've got Ubuntu all installed, or you can power off the machine. That's like press and hold for 4 seconds, and boom, down it comes. So we'll do that. And now ROS is powered off. And now we'll start again, and it will boot up and boot right into ROS running off of the hard disk.
Actually,
I'm
she's back.
sorry,
That's okay.
keep saying that. I've got a few notes in here. I'm not going to go over them, I think, in the interest of time, but got some instructions on how to set up networking, on where the power off or reboot button is in Ubuntu. Okay, there's Ubuntu. So now the next step is, you'll see that I just expanded the window, but Ubuntu is still configured as, I don't know, 640 by 480 maybe, whatever it defaulted to. So the next thing you want to do is to, under devices, insert the guest editions CD image. So VirtualBox comes with guest editions that give it things like screen resizing as you resize the window of the virtual machine. It says, contains software intended to be automatically started. Would you like to run it? Yes, we'll run it. And we'll give it our password, which was Bouchier. Okay, so now, and there are other useful things that the guest additions do is enable copy and paste. So you can copy out of your Windows screen and paste into your virtual machine screen. You can mount folders from your host onto the guest. So a lot of really swift things that come with the virtual editions. But the biggest one is being able to make the screen bigger. Okay, so while that's running, I got some notes here on configuration that you want to do. So what I normally do, so just orienting you around Ubuntu, this left-hand bar is the equivalent of the Windows taskbar at the bottom. And these icons that are pre-populated are the equivalent of quick launch icons. So I normally unlock, they use the term unlock from the launcher to mean, take it out of the quick launch. So normally I don't need, at least on this machine, you don't need, so this is OpenOffice that I'm unlocking here or disconnecting, because we're not going to write any Word documents or do PowerPoints on the virtual machine. Okay, this installing was done, so we'll return.
Have you already done an apt-get update?
About to do that, great question.
Gotta get those ugly icons off your screen first.
Yeah. Okay, so let's see. Ubuntu here on the right gives you reboot. So here's how you shut down if you want to, or log out or whatever. Okay. We will. Okay, I haven't rebooted yet. I will in a second. In fact, I'll do that right now. Shut down. We want to reboot. Just like a real PC. And when it comes up, it will be able to resize its desktop. Okay, I think, well, that's rebooting. There we go. It's fairly quick. Okay, a few optimizations, and now we can make this bigger. Okay, sorry about that. And oops, make too big. Now, again, continuing orientation. This thing is called the dash. It's like the Windows Start button, and it works kind of like Windows 8 where you can type in the first few letters of something, and so one useful thing is term, and you can click on this and get yourself a terminal. So now you've got a lot of power. Another thing that you want to do to configure it right away is to set up, type in appearance and behavior, and I like to show the menu in the menus for a window in the Windows title bar. By default, it puts them up at the top of the screen, which I think sucks. Okay, that's that. And then dash to lock, and we'll configure brightness and lock. And we'll turn lock off when and we won't require a password when waiting from suspend. So these are just some optimizations that make it work more smoothly. A couple other orientation things. Control-Shift-T makes a new tab within a window. Control-Shift-N makes a new window. So shortcuts from the slides. Okay.
Control-Shift-T will be your best friend.
Yep. You need lots of windows when you're working with ROS. Okay. Let's see. Just flipping back to slideshow for a moment. I put in some references here for learning Linux. One of the things that if you're using ROS at all, you'll need to know at least some basic stuff about ROS, like how to CD into a directory, how to remove a file or a directory, make a new directory. So those kinds of things are covered in these tutorials. You might have noticed Firefox in the launcher. There's also a thing that looks like a filing cabinet this thing that looks like a filing cabinet is the ROS equivalent of Windows Explorer. So you can like drill down into My Documents and
Ubuntu.
You keep saying that. Ubuntu. Okay. Choose a code editor. If you go to write any code or edit configuration files, you'll need an editor. gedit is a sort of built-in editor, but you might want to. I suggest you might want to do sudo apt-get install Kate. Kate is a context-aware editor in Linux that gives you context-sensitive highlighting. You know, so comments are blue and function names are some other color. Okay, I'm going to go back one because the last thing to do after an install was sudo apt-get update and sudo apt-get upgrade. Again, this is Linux orientation. Sudo, or some people say sudo, is a way of running a command as an administrator. So the username root is the Linux administrator, Unix administrator, and if you run sudo, it says run it with administrator privileges, and it'll ask you for your password that you typed in when you set it up. So don't set a password because it doesn't like it if you don't have one set at all. But do remember it. So that's what the sudo there is. apt-get is the name of the installer. It's like the program installer. Update means refresh your list of what packages are out there. Then upgrade means install the updates to packages.
When you're doing this, you'll see two things there: packages that have been kept back versus packages that will be upgraded. The kept back ones are like the same thing that happens in Windows when it needs to update core parts of the OS. It requires a reboot. So that you got to do a dist dash upgrade in order to upgrade those components. And then you're gonna reboot because it's replacing your kernel and a couple other things, stuff like that. So that doesn't happen a lot, but in this case, it's because we loaded off the ISO. There's been 4 or 5 kernel upgrades since then.
Okay,
And if you don't do it, the Ubuntu will be kind enough to bring up a little window that says, hey, you need to run these system upgrades. Click yes, type in your password, and do it for you until you reboot.
so we're stepping our way through, and we've gone through orientation, we've gone through Linux. The only thing I want to point out, in the terminal, I showed you how to open up a terminal. Control-Shift-C does a copy, Control-Shift-V does a paste. And they have to do something a little more unusual than Control-C and Control-V, because you might want to, Control-C, there's something you want to type in a terminal.
Yeah,
Okay.
It's break normally.
I've got a list of frequently used Linux commands for you here. Among them are sudo apt-get update and upgrade. Do that every time you start up your virtual machine, because it's sort of like Windows, or it'll run it automatically if you forget to. apt-cache search is a command that lets you search for packages. So if you're looking for a package for the Razer 9DOF, do apt-cache search Razer 9DOF, and sudo apt-get install, and then a package name installs new packages, and we'll do that here. That's how we're going to install ROS. ps-elf is a good, ps is like the task manager command. It tells you what processes are running.
Process status.
Sorry?
I think of it as process status.
It's pretty
Process
much what it
status,
is,
yes. Okay, so the ROS install is going to come next after we finish the upgrades, and I refer you to, first of all, to Agiter, the General Introduction to ROS, the book. These sections are very good, but they're a little behind the times. They were written for the previous version of ROS, so this wiki is the latest and greatest, and you always want to go to wiki.ros.org and
Copy and paste.
yeah, exactly. So wiki.ros.org has there's a huge amount of stuff here, but fortunately its search engine is run by Google, so if you want to search for something like Razer IMU, then it will bring up the usual ads by Google, plus it's got a pretty decent search engine behind it. Okay, how are we doing on our upgrade? Still upgrading. Okay, let's carry on a bit. So I'll step through this ROS install section here after it finishes upgrading and we reboot. But I'm going to move on in the interest of time. I've got some tutorial resources, the books and the websites. ROS by Example is a great book. Search the wiki. There was one more. Answers. I forgot to add answers.ros.org. So I'll do that right now. So if you have questions, go to answers.ros.org, and it's where everybody posts their questions.
And there's quite a few 100,000 of them out there now.
Yeah, so do a search first.
Most likely your question's been asked and answered
Yep.
until you get to the extremely advanced topics. Or my computer's doing weird stuff because I bought weird stuff.
Okay, I've got a set of instructions here for you on how to create and build a workspace, and we're running a bit ahead of the install here, so please excuse that. make do. So there are some, actually, let me go back to a couple of install procedure items here. Those of you who are new to Linux might look at this particular line here, as David did, and say echo, in quotes, source /op/ros/indigo /setup.bash, right, tilde /.bash. I say, what the heck does that mean, right? I think this is not too different from the DOS command prompt. So I think DOS has an echo or print, in quotes as a string. I think DOS has right arrow, doesn't it? Meaning add on to the end of a file. This tilde is a Unixism for your home directory. So it's always used as a shortcut meaning your home directory. .bashrc is a well-known file that always lives in your home directory that a shell executes every time the shell starts. And it's typically used to set your environment variables, like the path. So it's the equivalent of, in Windows, where you go into My Computer, Properties, Advanced, and then you set environment variables for paths and all kinds of things down there. That's what goes into .bashrc.
Except there's a space there
Where?
between the source.
Yes, that's it.
They're supposed to be.
It's probably scrunched. I believe there would. Did
If you
I
cut and
do
paste, it
that?
does work.
Yeah, it's a
Yeah,
space.
it's a space,
It
but I'm
just
just saying-
doesn't look like it.
I'm
Yes.
just saying.
Thank
for-
you.
For those who are not.
For those who are like scanning and saying, "Is that a space? Doesn't look like space." Okay.
Copy and paste, and then it won't matter.
All right. Okay, so we.
And that does work from these directions. I did it this morning.
Will it copy and paste?
It will copy and paste.
Yep. Okay, so we did our apt-get update, apt-get upgrade. So now we are going to take the next step and start installing ROS. So we copy and paste as Jason said.
The only problem are the line wrap things in there tends to get the new line character too. So you have to copy individual,
Okay.
tag them together.
If you do it from the wiki, it won't do that.
Right.
Doing it from the PowerPoint, it does.
Yeah.
Right, and this is an area where you really want to bring up Firefox, because I haven't figured out how to make cut and paste. Cut and paste used to work. I don't know why it's not working right now. But if we do go to wiki.ros.org and so it's this little double arrow thing means that's a network connection. So the virtual machine is on the network. It's got a simulated network, simulated NIC in it that goes through the host's network. And you go to install and platform Ubuntu, and you just copy and paste. We're running Trusty 14.04, so you just copy that, and then Control-Shift-V to paste it in, or if you've got a mouse with a middle button, that'll work even better. Set up keys. And then we do a sudo apt-get update to, so what we've just told it to go out to the ROS repository, to add the ROS repositories to its list of repos that it knows about. So now we're telling it to update and find out what packages are in the ROS repositories out there. And the next thing we're going to do, okay, so updated, now it knows about the ROS packages. This set of magic here, sudo apt-get, these install packages are necessary if you're installing 14.04.2. David ran into that problem. Thank you for alerting me to it. So we have to install them. because otherwise ROS won't install properly on 14.04.2. It was fine on .1 when I did the instructions, but they broke something.
They changed the core package library is what I'm running
Okay.
Stupid thing.
Okay. So, okay, and, see, I should try and make this bigger. Okay, so it's going to run along for a little while here. Here we go, it's finished. So now, the last command, and in some ways the most important, is sudo apt-get install ROS Indigo desktop full. And so this is the one that installs ROS. When this is done, we will have a clean ROS installation on top of a clean Ubuntu installation.
You only want to do this step on your workstation PC that you're doing the work on. So if you have like my Turtlebot, I have a laptop that sits on it. You don't install the ROS full desktop package. 'Cause I'm never going to run RViz on there. There's no reason for me to install it. I'm only install the libraries and components that are necessary for the robot that I built on the robot's laptop, or things that I'm playing with.
Okay, so Jason, that's a good point. So,
you have so in the ROS world, you really create two. You really create two systems. So the one that's in my bag is the workstation laptop. That's the one that has the full ROS desktop, the GUI, all the bells and whistles, all the stuff I'll probably never use until I figure out that they actually are there and I need to use them. On the robot itself, you generally only install the ROS packages you care about, the navigation package, the odometry package, the parts that matter for your robot, because you're not going to run your Ogre GUI on your robot's laptop because it's driving around.
okay, but if you go to the
So unless
ROS,
you're running after
if
it.
you go to the ROS wiki, they show, I want to say 3 or 4 packages.
There's
They
a
show
minimal
the full install,
Right.
then they call something, sounds like desktop full install, and then there's like a full install, which I'm not sure what the difference
Doesn't
is.
include all the RViz, it doesn't include all the visual components.
And then it has another level,
That's
which
the
is,
minimal install, which is what I start with. Most people probably would start with the one above.
so if I were going to try to put this on a Pi 2 or something like
You
that,
wouldn't do a desktop full.
you'd put the bare bones.
You can then install each package as you need it. So in the case of a Pi 2 or a Bigabomb Black or some other boxes, ARM-wise, you may have to build packages yourself for the processor you're on. Luckily, for the ones I mentioned, there's already somebody who has repositories with all that stuff pre-built. They don't have the full desktop pre-built because running while the Bigabomb Black or the Raspberry Pi 2 can display video and you can browse the internet, it's not an NVIDIA card sitting in there. It's not an Intel graphics card sitting in there. So while it has graphics, it's not necessarily a 192 core graphic card that is running your 3D visualization interface. So you don't want to. I've watched people do it. You just don't want to. It's
Okay.
4 or 5 frames per second, and you want to jump off of a cliff before your screen
Okay.
is done loading.
So,
So you're saying, if on Raspberry Pi, you want to do the basic?
You want to do the basic install, and there's and that's the newest Raspberry Pi has this. The older one doesn't. A repository you can go and just install the packages, and it's covered on the ROS wiki. It's the same thing. Get the base install, copy paste, copy paste, copy paste, copy paste.
Now, you put Ubuntu on it first?
Yeah. So there's an Ubuntu ARM that exists for the Raspberry Pi version 2.
Right.
the BeagleBone Black, the IFC 6410, the Droid X, there's a whole host of them out there. It's, that way you can run not a laptop as your robot, but you're still doing the same thing I'm describing. You only install your bare minimums on that and move and update and put packages on as you need to utilize them. Like the cost map analysis, the variable path planning, those type of things. You install those packages as you get to that level. That way you don't spend your time filling up your SD card full of stuff that doesn't make any sense to you.
Is the I2 a reasonable platform for this?
Sure. So I run an i5 to do what I do. Okay. But when this is at home, it has an arm attached to it, 2 3D sensors, 3 gyro, and an array of ultrasonics that sit on the bottom. Once you get past the first 3D sensor, the Pi ain't paying attention to anything else. Now the Pi 2 can, but it's still, you use a Nito if you want to do a laser scan, and you simplify it because it's not getting depth scan, converting that to laser scan, so on and so forth. You got to simplify your stuff.
So I'm going to go into a few demos now. ROS takes a while to install. It's sucking it down from the network. And so I'm just going to leave that. I've got the virtual machine running. I just minimized it. I'm going to leave that going, and we'll come back to it in a little while. But really what we've just stepped through is how to do ROS install. Pretty straightforward. So now I want to show you some things about ROS and explain a little bit about how to use it and the concepts behind it. So I've got a login. I did have a login. SSH. HB. Let's see. Find out what machine I'm on. SSH PHP. So I'm going to SSH into the netbook that's sitting on top of the laptop, and do a few demos here, and show a few things that you'll want to know how to do. So first thing I'm going to do is ROS launch. So ROS has got a lot of features, and one of the most powerful ones is ROS launch.
Excuse me, Paul. I'm lost here a little bit. So there's actually 2 different systems we're talking to.
Yes.
There's a laptop in front of you and another laptop on the robot.
Yes.
Both of them run Ubuntu.
Yes.
Both of them run ROS.
Yes.
Okay, thank you.
And are they connected to the DMS Wi-Fi? Or?
Yes,
Okay.
they are. Great questions, thank you. And you can tell by the prompt down here, PHP netbook, that I just logged into the netbook. The SSH is the way that you log into Unix systems securely. ROS launch is the equivalent of DOS's .bat file. It's kind of like a launch file is kind of like a .bat file, a script file, with one important twist. It lets you launch multiple processes or multiple applications at once in parallel. Because if you think about, you're composing a robot, right? You want to have one component that's reading the IMU, another component that's reading the LiDAR, another component that's running the motors on the robot, and another component reading odometry, and another component doing navigation. You need quite a number of processes running together. A launch file is how you define that. So, I mean, if you step back far enough, you'd say it's sort of like a .bat file, but it's got it's more powerful, and it's XML encoded and some other stuff. So at ROS launch.
Simple thing. Well, I mean, so it uses XML for the sense of what XML is created for. It's universal. That's why XML is created. Yeah, it's loaded. Yeah, it has a lot of scripted stuff in it, but that's why it's universal. So
Yeah. just as an example of of one of these files, I'm going to CD into RL500 just to
On my side.
RL500/launch. So this is the RL500 mower, and if we just look at minimal bring up.launch, less is more. So remember, less is more in Unix. You want to use less to look at files, and it's an XML file. The important things are the node a node is a process. It has a name. It has a package that it lives in. Its type is the executable. This one's an RL500 node.py. It's a Py script, and we give it a parameter. And then that's the end of the node declaration. That's one process.
So Paul, is it real time or is it time sliced or preemptive?
It's running multiple processes under Linux. So just, Linux does time sharing. It's not real time in the sense of an RTOS, which I think is what you're asking.
Yeah,
Got another node that's called RL500 odom for odometry, lives in the same package and has a different file name. Okay, so that's what we're going to do a few demos running this kind of launch file. So back on the netbook now, we'll run ROS launch. Now, ROS has got tab completion, so I just hit tab to tab complete, and then keyboard tab.
Linux has tab completion.
What?
Linux.
Right, you said right.
Yeah, but so does the ROS launch stuff too. So
Yeah.
it only, when you typed in ROS launch, it's utilizing the Linux tab completion stuff to only search the ROS related items.
Yeah, and
So it's
specific.
not-
Yeah.
So it's not the Linux derivative of everything that could be in this area. It's only the
I was
ROS
just trying to
related stuff.
straighten out, sometimes ROS and Ubuntu
Yeah.
in this
Yeah.
talk have been used interchangeably.
Yes, I'm sorry about that.
In this case, it's both, because it's a modified
Yeah.
way of doing it for the ROS specific stuff.
And so a little ROS orientation here. A lot of these commands will take arguments of the form package name, executable name, or package name, launch file name. So that's what's going on here. RL500 is a package name, and keyboard tell you off launch is the launch file.
Launch can launch other launchers?
Absolutely.
Yes, absolutely. And
In
there's
fact, most do.
And there's a lot of power in the launch file. One of the things about composable robot software, you can go so far with standardized names for topics that data is published to, but someone is going to break that sometimes, and it's got ways of renaming topics. So pretty powerful stuff in the launch file. Okay, getting this going. ROS launch is also powerful enough to know I wasn't expecting that.
That's what you just typed keyboard, buddy.
Just did what you told me.
Damn computers.
Don't they know what I meant?
Read the comments.
Okay,
That's what comments are for.
Okay. Motors.launch is a launch file that just starts the robot node listening for commands on the motors.
So basically like the turtle box minimum launch.
Yeah. Okay, so now we're going to go to another tab. You'll like lots of tabs here, like Jason said, and do a ROS launch RL500.
All the tabs?
Well, so in the situation that he's doing right now, he's on the laptop itself,
Right.
running the minimal launch, which gets the robot ready to receive commands. Now he's going to remotely control it with a keyboard, which is another launch file. So if you're doing it between two machines on your workstation, you can launch your keyboard launch file. And your minimal launch can be on your robot, and that's just one window on each. But in the situation of this, I have the minimal launch, the graphics processing one, the mapping one, and then I have the keyboard control and the RViz that you saw, so on and so forth. So when you get to the point that you have a stable robot base, though, You don't have to go through all that. You build a custom launch file that runs the minimal launch, that runs the graphic launch, that runs the mapping launch. And you just make it as a service. So the machine boots up, it starts the ROS stuff. You don't have to do anything. But while you're going through and building and working through your robot, you do it piece by piece. The same way you code a robot is I got my base, I have my navigation, I have my sensor readings. That way you can pull out the sensor readings, change some code, plug it back in. You didn't have to restart the whole base of the robot in order to do it.
So what we're showing, what I'm going to show now is, it says it's a TurtleBot, controlling your TurtleBot, but really I'm using composable software. The robot base is listening on a standard topic, which is called CMD_val, for messages that are of a standard type, which is called twist, that tells the robot to what direction to move in and how much angular rotation to give. So so in this window now I've got a UI running that will accept my keystrokes to run it. In the other window, what happened here? Did I switch windows? My ROS launch crashed.
Index out of it.
I think I better know what happened, maybe. Yeah, the motor powered itself off. Okay, and the software threw an exception because it couldn't talk to the robot. It's very reasonable behavior.
You need to have it like, have an arm to press the power button.
Yeah.
Exception.
Okay,
Like the iron alarms out, turn the switch off.
a little bit of, a little bit more orientation. When ROS starts, it tells you where it's logging. So it logs everything to a file. And unfortunately, they chose to give it a UUID here. But if we just mouse that out and go over. Okay, so here are the log files, and it makes a different log directory every time you start what's called ROS core. So ROS core starts up some sort of basic services within ROS. ROS launch checks to see if ROS core is running. If it's not, then it starts it, and it will print out the name of the name of the directory that it's going to send log files to. And here you can see that usually the log file that you're interested in is the one that's running your robot, or that's running whatever piece of software you're working on, whether it's a sensor or whatever. So here we would say RL500 node 2 would be an interesting one to look at. And so there are some info logs from the ROS node as it started up. And nothing I recognize that I actually coded in yet until,
And you can also adjust the level of logging too.
yeah. Nothing I coded in there yet, so that's fine.
Just the level,
Anyway.
not like packages or that. So just the level, not individual components.
You can individual
Yeah,
components
and the level.
and the level of
Yeah.
each component.
Yeah.
It's just like the
So good.
log for net or log for J or whatever, it says info debug, blah, blah,
Yeah.
blah.
So,
Debug is really crazy, like you would expect.
Yeah.
Only you want to.
So that's when I used the verbose on top of the verbs.
Yes.
But it wasn't enough. for these
Right,
guys.
right, exactly. 6 levels wasn't enough.
that's about as much as my robot does at the moment. but you all wanted to see a ROS robot, and this is my very own ROS robot that I wrote the driver for to control the module that controls the motors and the odometry.
The spinning plate.
And I got actually James did the little microcontroller that runs the LiDAR, and there's really, okay, so now you've seen a ROS robot move. As Jason said, we can do that from our own computer. So remember when I ran this teleop command, I ran it on PHP netbook. I ran it on the netbook. I was logged into the netbook. But ROS is equally comfortable working across a network. It was designed to work across a network. And so what I'm going to do now is do the same thing, only running it from my laptop here, running the keyboard teleop control from my laptop. Obviously the robot motor control is still running down on the robot because it actually deals with the hardware.
Okay, Paul, I wanted to ask a question on, so what you're telling me, what you're going to do here, if I understand you right, is that on your laptop that you're sitting in front of, you're going to issue a command where you're going to publish something.
Yeah.
And the fact that you've already turned on your robot, its laptop is out there on the on the network, waiting for a published message from any robot or otherwise I could have a laptop over here and send commands to yours too.
Yep,
Okay.
absolutely.
All right.
That's exactly right.
There are ways to make that not happen. So like if you only wanted to have it work from his.
Yeah, what I'm saying is that I was trying to figure out what Paul was actually doing.
Yeah.
Okay.
He's sending remote.
Yeah.
Yeah.
Now,
So-
are you doing it over a Wi-Fi or are you doing it over a?
Over Wi-Fi.
You can do it through other means.
So useful command is env, which prints the whole. There's a useful Linux command. It prints the whole environment. Pipe it to grep. Grep is a Linux program that filters, that looks for a match on the string that you give it, and only prints matching lines. So I asked it to print the environment, but only show me those that match ROS. And this one I've highlighted, ROS master URI, is an environment variable that ROS looks at to know where to go to the master. So there's this notion of a master in ROS that is effectively, think of it as a directory service. Every node that starts up and, as Doug described, listens for messages, goes to the directory service, which is what's called the master in ROS. And so we want to point, if we point the master at the ROS directory service running on the robot, then any ROS commands will go to that, will say, where's CMD-val? And it'll give it a pointer to give it an address of or a location of the robot. So we do okay, so export is the Unix way of saying set this environment variable.
The location and the organization at ROS at the physical location.
Yes.
Talking about robots and location.
Sorry, the network
No,
location.
I just want to make sure.
Yeah.
Yeah, so
There's some other thing you can
each
type
thing
to find out the
registers with
actual location.
each thing registers with the ROS master. So when you get into some crazy stuff like trying to determine the handle of a coffee cup, you can have a machine that only processes the point clouds of the objects you're trying to determine the shape of. That's sitting in your bedroom. That has nothing to do with the rest of your stuff, but it's running in the ROS image recognition system to determine the shapes of the objects.
Okay, I'm now driving the robot from my laptop. Okay, so that's just a demo of the ROS doesn't care where it's running. You only have to tell it where the master is, and it goes over there and
And that's a URL, so
Yeah,
The tasks are fetching that through that URL?
they're
using
finding the
the
master through that URL, and then they're going to the master and saying, who's publishing command? Actually, your question is a great one, and it's addressed on the next slide, so.
With wget or something like that? It's actually fetching the
Okay,
URL?
so here, this slide illustrates much better than I could in words alone the exact question you were asking. ROS Master, running over on my laptop, because that's where I started ROS Core, receives messages. And this is a hypothetical configuration where we've got a laptop, a camera hooked up to the laptop, and a robot base hooked up to the laptop. But they could be on the network, on any network anywhere. They just need to know where the URL of the master. And the camera node advertises that I'm going to publish images on the topic image. This is a CM Vision node that advertises I will receive images on topic image and publish blobs on topic blob. This is a control node for the base. No, control node that controls velocities. It says I will receive blobs on topic blobs and publish velocities on topic CMD vel. So, and then finally we have the node that runs the base, the robot base, saying I'll receive velocities on topic command vel. So this is all done through publish subscribe, and through the ROS master, each of these nodes that you likely started with a launch file goes to the master and says I want to either subscribe to this topic or I want to publish this topic. And anyone that says I want to publish it, ROS Master just remembers, okay, it's that guy that's going to publish this information. And anyone that wants to subscribe, he'll say, yep, okay, well, here's where you go, you connect it. So then the next stage, after they've notified the ROS Master of their desires, is that the camera node connects to the CM Vision node. So the directory, actually, the way it really works is the directory just tells each node that wants to subscribe where to find the publisher. So what IP and what port number to find the publisher of that information on. So the camera node, ROS Master told the camera node some IP and port number that it had assigned, which was where a CM Vision node is located. The CM Vision node got that from the ROS Master when it said, I'm going to publish. So then CM Vision node publishes blobs on this blob topic. The control node is subscribed to that, so it gets the location of the blobs and translates that into where does it want the base to go. It publishes velocities on command vel. And then the create node is subscribed to command vel and actually sends the messages at the hardware level down to the base and makes the base move.
So you're saying it's sort of like an internet directory?
Yeah,
Service.
that's exactly
service.
what it is.
Yeah.
It's a service directory.
Is there an order?
Different nodes.
Is there
Yeah.
an order? Do subscribers or publishers have to come up first, or there can be?
No, they can go up and down independently. The only thing you'll see that's different between one case and the other is it'll print out a warning saying if a topic isn't currently published. Like say, CM Vision node happened to come up. Actually, your question first, if you launch it manually and the camera node hadn't started yet, it would just print out a warning saying it's not published yet. But it'll still listen, and ROS takes care of hooking it up when the publisher does come up. And what that lets you do is the publisher can go down, like it might crash, you start it again, and it carries on from where it left off.
Okay, so let me think, here I am trying to build a ROS robot. I'm probably not going to build the camera node. I'm probably not going to do the CM Vision node. The control node, obviously I've got to have something into that because I have to translate blobs into velocities.
Mm-hmm.
So that would be my,
Yep.
but that would still be on my laptop, right?
Yeah,
Okay.
you'd run it. Yeah, you'd likely run that down on the robot just for performance.
Okay.
And
Yeah, it would, so when you're running it locally, there's also things in ROS like shared memory and things like that. that make it so the image doesn't have to transfer across the pipe.
So what I'm trying to get at is, so you got an iCreate there, so on my little iCreate base, do I simply have to create a program that will receive the command velocity format and call that a node?
Yeah, and that's
Alright.
exactly what I did here, and it's all of maybe 100 lines of Python.
If you choose a much more known base like the create node, you don't do
I'm sorry, I didn't hear you.
If you choose a much more known base,
Yeah,
like the create node, you don't write anything. You just
It's
install
already
the
written.
create node.
it's all probably already
It
written.
is written.
Yeah.
So it's common for Arduinos, standard motor control interfaces, those type of things.
Okay, so the only question that remains to me is the control node. The control node, you're saying it could either be down on the create, or it could be,
So it could be keyboard teleop, which you could run off of this laptop. Or
Okay.
it could be something that actually is using real logic.
okay. So if I put that node down on my robot, I'd have to be able to somehow interpret blobs, which is not, it's probably just the location of blobs. So, okay, I got you.
You've got flexibility. It's not a question of what could you do, it's a question of what should you do.
Okay, one last question that I have is, do you guys have the NITO
Yeah,
LiDAR working?
yeah.
Yeah.
Okay,
There's already a module for that. You just
okay,
install
all
it.
right.
Yeah.
Cool,
And if you go
cool.
on the ROS wiki, you'll actually see an image that I made in this very room as a demo of, here it is working.
Okay,
Yeah.
that's cool.
It's done, it works well,
All right.
and it's fast.
Um,
Much faster than 3D lasers, 3D depth scan converted to laser
Yeah.
scan.
So this topic, this question of topics and nodes publishing topics is a very central one in ROS, and it's what gives it's what gives ROS the property of composability. It's the use of the standard topic names, standard message formats, coming out of things like IMU nodes and camera nodes, and going into base movement nodes, coming into and out of navigation nodes. It's that use of standard names and standard messages that you can bolt together in a launch file, depending on what hardware you've got in your robot, that gives it this property of composability.
Okay, let me ask a dumb question. So you're saying that you could, in principle, build a simple dumb robot by taking a Pi 2 and putting an Arduino on it to control the motors?
You can probably use the Pi 2 to control the motors if you want to.
Yeah, that motor controller for Pi 2 too. So.
Get a USB motor
Yep.
controller.
Now, what you're gonna wanna run into, I mean, personally, if I were in your situation and was going down that road, is I would do a little bit of research on what was already coded to. So, a way to do it would be like, if you're gonna go down the Arduino road, use an Arduino Mega, get the Robo Galileo motor controller, and quadrature encoder reader.
Yeah.
That way, you don't have to write your odometry code, you don't have to write your motor control logic. That's just done, you put it on the Arduino, now you can make it move left, right, and understand theta.
So you're saying, see
and-
what hardware and software
Right.
is already there?
And you'll find that
Yeah.
if you want to create it yourself, which is great, and I've done it, that you'll probably spend 4 or 5 times more figuring out what actually does work versus going and spending the $75 on what already works and is the same thing you would have made in the long run. Anyways, so
David, you had a question?
I just don't know the word composability. You've used it several times. Can you define it?
Yeah. I would express it as the property of a system that lets you compose of an architecture really, that lets you compose complex systems out of smaller components. So as an example, Legos are great. You can compose buildings and vehicles out of Lego bricks. Unix is a good example where it has the pipe, so you can pipe together PS, pipe to graph, pipe to send, pipe to this, that, and the other. you can compose things that do just what you want out of smaller components. And that's really what ROS is about. That's how it solves that. Remember at the very beginning that the PhD student's problem of having to rewrite everything. That's how it solves this. They can take these fine-grained components, and for most of their robots, it's the same as everybody else's robot, and then just plug in their special little sauce. Okay. Was there a question down there?
Yeah, a question. The communication, say like, Jason was saying, look for hardware where the stuff is, where the, I guess the processes are already written for it. That's the correct thing to call them. I was kind of curious, is that done, like is there a kind of a parsable string that has a set format? Is that kind of the basis of that, of communications between?
So it depends on how the person wrote the robot bit. So I can give you a couple examples. In fact, Paul demonstrated, and we have a DPRG video for ROS serial, which is which is sending serial commands across the USB serial interface to an Arduino or to some other controller.
Yeah.
There are people who've come up with other ways of doing the same form of serial communication because they didn't like complicated XML objects being traversed across the serial or various other ways. So they said A2 means this, A3 means this.
Oh, okay.
Type junk, okay?
Right.
These are the messages that come back. So there's interfaces for Robotics controllers, there's interfaces for Arduinos, there's interfaces for all that stuff, and you load your base library on the Arduino. This is how I'm going to talk to ROS. Then you do your control that you need to get the information from to send back up to ROS. And so, but you're still passaging messages back and forth.
Right.
This is my odometry. Great, I understand your odometry message. This is my, this is what I read. This is what my gyro reads. This is what this reads. And so you can choose the interface that best suits what hardware you chose. If you're using a Pi or something like that, just it's a Python package. If it uses an Arduino, it's a standard INO. And robotics is along the same lines. It all just depends on when you get into some of that stuff, you start to have to worry about memory constraints and things like that. So then that's why the guy came out with A2 means drive forward.
Right. Yeah.
Because he was tired of having to parse the 62K character string to determine you wanted him to go forward.
Yeah.
Okay.
This, I think maybe just.
You can search for those things on ROS Wiki. Almost everybody documents their packages on that. And if it's not there, Google is the next obvious variety for people who are starting but haven't necessarily got to the point of publishing it to ROS Wiki yet.
Okay,
Unless colon and
sure do. Sorry, HTTP : yes, thank you. : thank you. Okay, so a useful tool to try and understand these. Someone said down the back said, are they called processes? Are they called nodes? They're called nodes is what ROS calls them. They're really processes in Unix lingo, or but ROS calls them nodes. So these square boxes represent nodes that have publishers, and here we've got, this is showing a Teleop keyboard process that is publishing on topic CMD val to an RL500 node. This one is actually running on my laptop right now, and this one's running on the netbook that's on the robot. So it's a tool to help you visualize the connection of nodes using topic names.
And it's better if you start using this early and getting used to looking at it. So once you start building layer upon layer upon layer upon layer, you'll want to
It can get
you'll
complicated.
want to understand
So you
why
don't
the hell the
pause.
command you inserted
Yeah.
here
Yeah.
isn't making it down here, or you know.
So.
Okay,
what
so
tool-
we've
What tool are you drawing
gone-
those graphs with?
What?
What tool are you drawing those graphs with?
It's RQT graph. It just
Okay,
comes with everything that you need.
okay, thanks.
We've done a lot of this stuff. You can actually manually publish. There's a command here that will manually publish on topics. If you should wish to, for test purposes, you want to like send a motion command. So that gives you a lot of debuggability. I'll tell you where I was going to go next, and considering that we're a bit short on time, give me some feedback on what you guys think is most important.
Do we need to have a second session on this? It seems like you've gotten through about half of what you intended to.
I'll second that motion.
All in favor?
We'll just have to pick a time. That'd be fine. We'll
Pick a
just have to pick a
different day
time.
and a day that you're in town?
Yeah.
When are you in town, Paul?
Every 2 weeks.
So,
So in 4 weeks, I should be back. Except I think I've got something else going on that weekend. We can work it offline.
well,
Actually-
let me pass one other idea.
And on Tuesdays, you feel free to come in, and if I'm around,
Okay.
I can walk you through any of the further
Yeah.
stuff.
Well-
It only looks like I've got a lot to go. Actually, there's just one kind of wrap-up slide that I think is worth talking about is ROS right for me? The other major topic or significant size topic that I was going to go through is a little bit of C++ and object orientation. Who feels comfortable with object orientation, OO programming, or who? Okay, so quite a few of you guys.
It's not in Python.
In Python?
It's
Okay.
not in Python.
Not in Python.
Not in Python. Okay, so maybe we don't need to, I was going to walk through some basic syntax in C++ for that.
Probably not. I think,
Okay,
yeah.
C++ is better than Python.
Answer your question. Is ROS right for me?
okay. So, first of all, what is ROS? So it's middleware. Middleware meaning it's not a device driver, it's not something in the kernel, it's not a database. It's something that sits in the middle between hardware and low-level stuff that talks to hardware like device drivers and the applications that sit above them. It includes inter-process communication mechanisms and a software launcher that we've seen. It's also a community, and there's software packages. There are 1,500 software packages that have been contributed and that you can draw on. And it's also a development environment on Linux for building and running robot software. So it's a multifaceted thing. It's not just a piece of inter-process communication, it's also a community. Is ROS right for me? Well, I think if you're going to write in ROS, you want to be decent at C. There's not that much that's real heavy C++ in ROS. But there are a few things that kind of like that are idioms that they use that do rely on some more advanced C++ isms. But once you recognize the idiom, then an idiom meaning something in code that is like in a way of expressing an idea. A pattern.
Another software
Yeah.
word that's overused for other things.
Yeah. Like a one-liner. Okay, so you want to be decent at C, I think. You want to be comfortable working with big software systems. So what that means is a lot of times you have package dependencies where you install a TurtleBot and it don't work right now off the shelf. You call Jason and you say, Jason, I'm having this problem, and he says, well, go blah blah blah. I think you want to be comfortable because you'll find dependency issues. You want to be open to learning enough Linux, and maybe Python. You don't have to know Python. ROS supports both. You'll be glad, it will be good for your general education, and you'll be glad in the ROS environment if you do learn Python, because it's a pretty compact and powerful language. But you don't have to know it. C++ works fine, is fully supported. You don't have to know that much Linux, but you've seen I've used a few things like PS and grep, and I've got a Linux cheat sheet at the end of the slide set. You want to build more capable robots than is possible from scratch. If you don't want to do that, then David.
I'm not convinced that's true. I haven't seen any evidence of it.
Well, I challenge you to hook up a Connect to JBot and interpret the environment around it and navigate based on what it sees as in a depth image. That's what I'm talking about, building more powerful robots than you can build yourself. Because frankly, without any offense, I don't believe you'll write a Connect driver, much less a 3D point cloud library to interpret it.
I'm gonna have to hold Ron in his chair back there. You got people
But Ron might be able to.
You got people who write drivers for a living in here, so be careful.
But I think the difference is, do you want to spend a week doing it, or 2 years? Or 10 years, or 15 years getting your base perfect?
Obviously, David wants to spend 20, 15 years on things.
He has spent.
Finishing up, please, we'll have these arguments and you guys can go on whistle after the meeting.
You're fading out.
You're fading out.
You're fading out.
You're fading.
You're just fading. And on that note.
And are you open to using PIP modules that other people have developed and learning enough about them to use them properly?
Which is where the Python comes into play, to be perfectly honest with you.
You mean learning enough about them to fix them?
To make them work.
To make them work in your environment.
So there may be variables and things like that they name slightly different because that's the way they wanted them to be, because they're, orthodox variable naming people or whatever. You want to go back in and make that a little bit smoother for your world, so.
So you know what Jason spent his 700 hours on?
Is trying to understand that
Is
crap.
really
Which David doesn't want to do.
So if you don't want
Coach and I write
to understand, to learn enough about other people's modules, then you won't be able to build more capable robots that is possible to build from scratch. And so I think these are the questions that you should ask yourself, because ROS is no doubt it's a significant climb to get up on it from scratch, but it carries a lot of power.
So going back to that in the earlier question, rephrasing it, at what point do you get back all of your investment in the learning curve here, such that you're now that much more productive and more complex robots?
Well, so
How many
I
hours?
think you missed that.
$700.
Yeah, I think you missed the earlier part of the meeting
No,
where
I
that
was there, I heard it.
at the very beginning,
Okay.
when there was a blatant question asked about mine. So when I came in today, I had nothing written for the navigation of the robot
No,
that went
I
around
heard
the room.
that.
That
I heard that. I heard
45
700 hours or whatever.
and 45 minutes when they actually do the work once I came in.
That's not what I'm talking about. I'm
So-
talking about over your entire learning curve of starting into the ROS experience, if you
Yeah.
like. At what point do you get back the time that you've lost? What's the crossing point?
What's the tipping point?
Yeah, where.
It's a hard question
Where's the
because
answer?
I know
how
it's complicated
truly
of the
answer.
nodes you're using.
Where's the
right?
answer?
I mean,
Yeah,
if you're
because-
dealing with complex mapping vision, that's likely to pay off, because like you're saying, it would take 6 months to do your own there, or a year or 2 or 5, whatever. But odometry or something like that, obviously, you could sit down and craft out your own PID controller, whatever, just, do a few quick lookups on Wikipedia.
I
or how
wouldn't even
PID
bother
works.
if there weren't vision involved.
Yeah, so,
There you go.
so
It's probably
I'll
not
tell
worth
you,
it,
so when I took the Club Turtle bot, I actually had no precursor knowledge whatsoever, other than I knew Linux because I lived in that world, due to my job. It took me 2 weeks to get to the point that I can do all the tutorials, and I was making my own stuff and processing vision, working with blobs, traveling around in maps I created, understanding gyro messages, and creating my own software above it, and doing things that I had spent the previous 2 years trying to do on my own custom stuff with my own software. And because I suck as a coder, unlike David over there, I require other people's code in order to be able to do that well, because while I might enjoy the math of how to derive theta from X and Y coordinates, I don't want to freaking write it every time that I go to a new platform. And I know you can do libraries and all that other junk, don't get me wrong, I hear you. It just gets to the point that if you don't want to repeat that cycle over and over again, I think it's the right way to go. It's just...
Another answer is it depends on what you're trying to do. You know, if you've got a problem that can be solved by RoboRealm, for example, a vision problem, go that route.
Yeah, because
the learning curve is so much lower. But if you're trying to make a new base, trying to use new sensors that aren't supported by packages that you can get, to do relatively sophisticated navigation compared to what RoboRealm or you could code, for example, the path planning kind of stuff, then think about ROS.
Well, so I'll give you an example too that helped convince me. So I got to a point where I was extremely frustrated with ROS, mainly due to people's code that I was having some issues understanding where they got to where they are, which I got past that. But what convinced me to continue going down the road is the repeatability of what I was able to do without even using my robot. I can record what happens in the environment while I'm doing a specified task with my robot. I can record all the stuff that happened, all the sensor readings, all the world that it absorbed, and then I can go and change my code and replay it through the section where I had issues over and over and over again until it starts to respond the right way, and I can tune and tweak my algorithms without having the robot to waste the battery or driving back and forth in the same area over and over again. And I can do that for a long period of times. If I want to change my vision system to detect blobs slightly in a different way, I can see without having to go through this, without having to have the same exact world set up over and over again, what I previously did, replay it, see how my vision system adjusted, how the commands would have been different, see if that actually path worked better, so I can adapt without having to repeat. It's more than simulation. It's pure debug. You can anything and everything that happened in the ROS system, you can record it to this little package and replay over and over again until you get until you want to get the results you wanted. They do have a simulation world where you can build your own simulated environment that gets on a whole nother level of holy crap. But
yes.
So how much of it is in Python and how much of it is in C? I mean,
So I think the right answer is that C++ and Python are both fully supported. If you want to code anything,
I mean, like under the hood, what is ROS itself written in?
C++.
But most people write packages in Python.
Right, and so that's why it would be beneficial to you, aside from any other reasons, to know Python, is that you can look at existing code and read it and say, oh, that's how they did it. Okay, and then let me tweak a little.
Well, I mean, and that comes down to not everybody who works on ROS is a coder. They may be they may be a vision expert. I hear, but I don't understand the hate. It's an extremely structured language. I can do in one line what takes you 200. I can.
Yeah, but it takes you 200 cycles to what I can run in one. So.
Sure, but so then you
did. Okay, this is a religious conversation. But that's not important.
All right, gentlemen, before anybody leaves.
Okay.
All right, I saw one more question. We're gonna let that question go. But remember, we have a raffle for a free JetBrains license on one of their products that if you want to participate, stick around and get a piece of paper and write your name on it.
And before you guys go, I need, anybody interested in joining the Maker Fair, I need your name and email address.
Yeah.
So we can schedule people.
Which one,
Yeah.
is that the Fort Worth one?
Yeah.
At the end of March?
Okay? All right.
I'm gonna stick
There was a
around
question.
if anyone wants a hand.
I don't think the next guy's here.
Oh, well, we can do it outside.
Do you have a question you want?
ROS looks like it's just a message, it's built on top of a message. And so you have publish, subscribe, and notifications.
something,
Yeah, what's it using underneath? Is it using a rabbit queue or? Well, okay, because there's like, you can grab like a rabbit in queue, which is just a message.
But so when this was started, Rabbit Q didn't exist, so why would I grab it? You know, there are people who want to grab it now.
Actually, Ross is going to move to DDS, supporting DDS.
No, it's here.
Yeah, at the time it started, all those things were in the
Planetary is a TCP.
Okay, then I was thinking maybe you guys come in and you're out of south. That's all right. Come in.
All right, guys, let's give Paul